Hi, this is David NG, and today we're gonna take a look at the squeeze theorem and what is squeeze theorem. So what the squeeze theorem says is that when we have a limit of a function, let's say x approaches a of f of x, and it's equal to limit of x if of x approaches a of g of x, then if there's a function of h of x between f of x and limit and g of x, and we can write it as limit of x approaches a f of x, and then remember what I said. I assume there's a function h of x between these two f of x and g of x. So as I write right here, so let's say this is a limit between these two functions. And so what the squeeze theorem says that if the left side and the right side are 0, let's call this L, right? Let's call this L, and let's call this R. If L and R are both 0, then the middle, what the squeeze theorem says that is the middle is definitely going to be equal to 0. So today we're going to look at some applications so you don't get too confused over this matter. So last day I took a look at an example of limit of x approaches infinity of sine x over x, and what that's going to be. Well, that's going to be equal to 0. Well, we kind of did prove that graphically in my last video, but today we're going to use squeeze theorem to prove that it is actually going to be equal to 0. So let's review some concept before we actually start talking about this. So did you remember that you learned in earlier math that for sine function, it's like a wave like, right? And it's always between -1 and 1. So you could draw the sine function like maybe like this, right? It's always between 1. Its maximum is always at 1, and its minimum is always at -1. So let's write that property first, okay? -1 sine x. So what this is that the function sine x is always between -1 and 1, because it doesn't go down up far or it doesn't go up like lower down, right? So it's always between -1 and 1. So now let me ask you, how are you going to turn sine x to sine over x, right? You simply divide sine x by x so you can get sine x over x, right? But remember, what you did to this, you have to do to the both side too. So what is that going to be? That's going to be, let's write that, -1 over x of sine x over x of 1 over x. So what I'm basically doing here is converting sine x into sine x over x, so we can use this equation, right? And as we do that, we have to do that to the both side, which we have to divide x on the two sides, right? So what is the next step? Well, the next step is substituting that into it. So what does this say? This is a limit as x approaches infinity. So let's write the expression first. So limit of x approaches infinity of -1 over x, limit as x approaches infinity of sine x over x, and between limit of x approaches infinity of let's say 1 over x, right? So this is going to be 0 and this is going to be 0. Well, you might ask why. Well, I have a pretty good example of visualizing this. So let's use blue pen. So this indicates that this is not part of our question, but let's write that. So we have limit of x approaching infinity of 1 over x. Whenever you have a fraction, when you have x on the bottom, so think about it. What happens when infinity is on the bottom? So what does infinity means, right? What is infinity? Infinity means like a very big number. Well, it's not like exactly a number, but it's a concept. But you do realize that it represents something very big. So let's see. How about 1 million? Is 1 million big enough? What is 1 million over 1? That's a very small number. So now do you see the pattern? Infinity is a mathematical concept that means it approaches infinity, right? It's not like exactly a number, but as you can see, as the numbers get bigger and bigger and bigger, the number gets smaller. So as that approaches infinity on the bottom, that function should be equal to 0, right? So that's exactly why these two functions are equal to 0. And then now what do we do here? So like what do we say between the squeeze theorem? If if I have a function squeezed, that's why it's called squeeze theorem, right? We have a function squeezed between two functions, and if the function f of x and the g of x values are both 0 in this case, right? Negative 1 over x is 0, and 1 over x is 0, right? So if these two values are equal, then the middle value must equal to 0 also in this case, right? It's kind of saying that what the squeeze theorem is saying that if the left is equal to L and the right is equal to L, then the middle must be equal to L2, right? That's why it's called squeeze theorem. It's squeezed between two functions, right? So we can rewrite expression as 0, which is this going to be equal to, which I explained here. So between limit of x approaches, let's not write that as 0 first and kind of explain it a little bit. 0, right? So according to squeeze theorem, whenever you have two same values squeezes together, and then the middle must be equal to it. So remember what I said? If the left is L and if the left is L and the right is L, then the middle must be L2. So therefore, I just proved that middle limit of x approaches of infinity of sine x over x must be 0 through squeeze theorem.